caused by humans or that it's a hoax brought up by the Chinese. However, we do want to point out that these changes are evident and happening in our planet. One of these places that is affecting is our ocean, and these effects take time to reveal. However, they are now becoming very evident.
Currently, I'm a marine science major here at Cal Poly, and over the course of my schooling here, I've learned about the many different effects of climate change in our oceans, and today I would like to talk to you about the current state of our oceans in relation to climate change.
And as an environmental management major, minoring in biology, I had a lot of fun being able to research a topic that let me synthesize my curriculum well, and I plan to talk to you guys about the future effects of climate change and how it'll affect our oceans and our marine life.
And as a city planning major here at Cal Poly, I have learned about the stressors that affect urban regions, and today I will talk to you about what these effects are to humans and how the ocean changes will affect our activity.
Our oceans obviously play a critical role for humans and all other organisms alike in some shape or form. They're a critical resource for food as well as just a place for many organisms to live. There are many problems currently due to climate change in our oceans, as fisheries and coral reefs are two crucial factors for the health of our oceans that are affected negatively currently. In the article, Can Marine Fisheries and Aquaculture Meet Fish Demands from a Growing Population in a Changing Climate, Gorka Marino stated that there was the global fish production was 140 million tons in the year 2008. Since then, the population has grown in terms of humans, and because of this, that is related to the production of fish, which is needed. We will continue to need more and more fish as our population is expected to grow to much higher numbers in the future. With the changes in our climate, there are alterations to many habitats in our ocean for many aquatic organisms. We as humans rely on these organisms for both means of food as well as our livelihoods in different regions of the world. As we've seen over the years, there's substantial variability in our world climate, as some years may be colder and whereas some are hotter, and this is often changing each year. This makes it difficult to predict our future as to how the climate will affect our fish production. As you can see in the graph, it has just been an increasing slope upwards, and the blue is the aquaculture production, which is where we are fishing, like making fish farms, and the capture production is just for what fishermen capture out in the open ocean. So with the difficulty of predicting the future, we as humans will have to figure out a way to maintain the amount of fish which we need to produce each year, as well as increase our open ocean catches. In the article, Safeguarding the Future of Oceanic Fisheries Under Climate Change Depends on Timely Preparation, Jim Salinger and Alistair Hobday stated that our ocean warming has increased in the stratification of water in our water column and reduced the supply of nutrients even in the mixed layers. Oceanic changes are due to global warming are altering the food webs that support fisheries and leading to permanent shifts in the distribution of fish. Such changes are currently happening all over the globe, and fisheries will have to be able to prepare and adapt for the future if they want to keep up with the growing population. Another massive impact of climate change in our oceans is the bleaching of coral reefs. Bleaching of coral reefs is due to the increasing of temperatures in these areas higher than the organisms which live on these corals can adapt to. And as you can see in this graph, over the past century, almost everywhere on our globe, the temperatures of our oceans have increased substantially by upwards of 2 to even 4 degrees Celsius. And here's a picture of a coral bleaching occurring in progress. So the white area is where the water has already started to become too acidified, as well as the temperatures are too hot in the ocean, and that's why you can see the algae on the sides is starting to come off the coral. In an article by Ray Berkelmans on the thermal bleaching thresholds in the Great Barrier Reef, he states that the sea temperature is strongly associated with coral bleaching, and that the evidence remains that that elevated temperatures are the primary stress factors in widespread events of coral bleaching. As this goes to show, climate change is the main reason why our oceans are taking a hit on our coral reefs. As our warming atmosphere continues to be polluted by other things in which us humans have caused, this relates into our oceans and is the reason why there are increased temperatures. Therefore, coral bleaching is happening globally at unprecedented rates, which we are unable to predict at the time, and that we have to figure out in order to know what our future holds in our oceans. The effects of the ocean are global, and climate change is directed more towards our corals and shallow regions because of the proximity to the sun and other heating causes in the ocean. Andrew Hoey stated in his recent advances in understanding effects of climate change on coral reefs, he addresses the problems for reef fishes. He says that elevated ocean temps may be expected to lead to earlier onset and shorter breeding periods for the tropic regions compared to higher latitudes. This also relates to the temperatures of our oceans, and as the equator continues to get more and more hot, this will relate to the deaths of many other coral reefs across the globe. This is not a normal occurrence and would not be happening if it were not for climate change in our oceans, there will be continual increasing dangers to many reef organisms. This has become a prevalent problem, and our ecosystems will continue to deplete in the future to come, and this will only make life more difficult for all organisms alike. Now, Trent would like to talk to you more about the future of climate change.
Alright, so I want to discuss the future trends that are happening in our oceans and how it may alter the ecosystems and the species that are within those ecosystems. So I'm going to focus on increased water temperature and ocean acidification for my main two topics. And I'm going to be using models and projections to help display my findings, but I want you guys to understand that all models are wrong and there's always a certain margin of error for models. So in my research I tried to find highly statistical evidence to make sure that there wasn't too much skewing off from the data. So the first topic I want to talk about is the effect of warming temperatures. This graph right here shows a world map of projected surface temperatures for the late 21st century, around the years 2080 to 2099, compared to the late 20th century, like the 1990s. So as you can see, there is a substantial change in the continents, and especially in the poles. And there is also a difference in temperature in degrees Celsius for our oceans too. Dr. Needles, a professor here at Cal Poly, found in her studies that by the end of the 21st century, surface temperatures will increase 4.5 to 6.3 degrees Fahrenheit for the coast of California. And although these may seem like small changes in temperatures, it will lead to large and dangerous shifts in the climate and the weather. Oliver Fuller and others studied New Zealand's coastal environments, and they found that the predicted changes in global climate will also result in the changes in season in which coastal environments are most similar to. So basically, seasons will be happening at different times, like spring will be occurring earlier since the temperatures are warmer, and species with reproductive, hibernation, and flowering patterns, if they're plants, are going to be thrown off by this. And like Ryan said before, along with just fish, all other species are going to have to shift their ranges and distribution to probably higher latitudes, away from the equator and towards the poles, since the water is warming. And since since all species cannot adapt to these changes so quickly and they can't migrate that fast and quickly, this may lead to both population decline and the extinction of some of our marine species. These higher temps also result in raised sea levels, which is due to thermal expansion. However, I'll let Jerry talk more about rising sea levels later in the speech. Warmer oceans also cause thermal stress that contributes to the bleaching of corals and infectious disease, like Ryan noted before. Here's another visual just to give you guys an idea of kind of what coral bleaching is like. Over here we have like a healthy coral, and after increased water temperatures, that's what it looks like, bleached and dead. And since the reefs are going to be eroding they're going to be eroding faster than they could be built, so this will lead to a loss of habitat for many species that live in coral reefs. Alright, so coral reefs are taking many blows from the climate changing in many different ways, which leads me to my next topic, which is ocean acidification. Ocean acidification is the increase of CO2 concentrations in the atmosphere, and since the ocean ends up having to take up more CO2 since it does absorb a lot of it, and carbonic acid is a product of it, the pH will go down and it will make it more acidic. This graph is taken from the IPCC, the Intergovernmental Panel of Climate Change, and it's kind of blurry, but it basically displays atmospheric concentration going up, and it's a projection from the year 2000 to 2100. And I just wanted to basically show this correlation of the CO2 going up and the global ocean pH continuing to go down for basically the rest of our lifetimes. So the coral reefs basically they basically receive a decrease in growth and structural integrity when as a result of ocean acidification. The National Oceanic and Atmospheric Administration, otherwise known as NOAA, released an article that said that not only will it affect corals, but also other calcifying species such as oysters, clams, sea urchins, and calcareous planktons. And this will end up disrupting the entire food web and can lead to cascading effects in the ecosystem. And I just wanted to bring up a particular case study that kind of shows the effects of ocean acidification. So right here is a pteropod, which is a tiny sea creature, and they are eaten by organisms that range from krill to whales, so they're pretty variable in the food web. And they also serve as a major food source for North Pacific juvenile salmon. And basically shows you how, this is basically like a study case that showed the pteropod's shell placed in seawater with pH and carbonate levels that were equivalent to the projected levels in 2100. So as you can see, from days 0 to 15, it's doing fine, but after a month, it begins to disintegrate and ends up being useless for the rest of the ecosystem. And not only is it happening in this guys, but it's happening at smaller and larger scales. And it's important because billions of us rely on the ocean for food, and many jobs and economies rely on fish and shellfish in our oceans. So now Jerry will talk to you about the effects on us with climate change.